Cool. Next over.
Yo, Anthony.
Oh, hey, how's it going?
Good. Recording it for my mom
Oh, awesome.
and everyone else, I'm sure.
Sounds good. Yeah, so here's the overall project and everything. A lot of the work we've been doing. But yeah, I'm pretty excited.
Do you want to walk us through what you've done?
Sure. Yeah, here's the project. We're doing algae photobioreactors for carbon dioxide removal. A lot of this has been focused around removing carbon CO2 from the process streams. So here's kind of a general introduction, pretty much on the process. So a lot of our industries that use today use a bunch of CO2 emissions in the atmosphere. So generally, that's not a good thing. So our whole process is kind of like get an input stream of gas and just pretty much remove that CO2 from it. So we originally built these reactors to house algae and our gases, anything that goes into it. So we want these reactors to be under pressure so that they have so that the pressure promotes more growth and conversion of CO2 into oxygen, because as the pressure increases, the CO2 will go down into the water, and thus oxygen is converted. So that's the overall kind of design process. So it's a very flexible system. It can be implemented in a lot of different systems, and you can have it stacks and stacks and many rows of all these reactors. But unfortunately, due to some complications and stuff we had during the semester, we had to de-scope the project and transition over to these smaller scale reactors right here. So yeah, pretty much the same thing. So algae in the water, and then we have like a gas mixture of CO2. So and then the CO2 will go into the algae. The algae will eat it up, will grow, and produce oxygen.
Awesome. And where's the rest of your team?
They're all about. So we have Bill right here. And so I think they're out to check out. They took a break, like snack break.
Oh yeah.
So we're doing shifts right now. So yeah, kind of overall general results from us. So the overall general reaction of converting CO2 into oxygen that happens by the algae. And then we did our test on those little serum models for a course of 6 days, and we were able to graph results of that. So that's what is shown here. So we had a mixture of oxygen, nitrogen, and methane inside our bottles. That's what each of these peaks represent. So this first peak right here is oxygen. We got nitrogen right here. This last one is methane. So we're really focused on the whole oxygen portion of this. So as you can see, so this is a single sample over the course of 6 days, and it does. So on the very first day, we have very low concentrations amounts of oxygen, but as the days go on, the peak gets higher and higher and higher into our final day. And then the final day of all different concentrations, so we kind of see similar trends with that.
So in conclusion, the big fundamental is the CO2 turning into O2. That way we mitigate the CO2 emissions, and we can have a higher concentration of our natural gas, which can be used to power industrial factories such as this one and large trucks. That way, if the project goes big scale, like throughout many countries and stuff, global warming can be mitigated.
Very cool.
And these are the references that we have done.
And who are you?
I am their third partner mate, Daria Al-Shumari.
All right.
So yeah, it's been a very, very fun project. Yeah, just as Ari was saying, we collaborate with a lot of people. So people both in the U of A and outside of it, and so yeah, it's been very fun and very, very excited over the work we've been doing.
Very nice.
Yeah.
Oh, very cool.